Welcome again to the part 11 of our meta-analysis tutorials. So for today, I will use again metagen function. If you remember last time, I demonstrated this figure. So if you remember, these are the main functions that we need for depending on your type of your outcome. So for correlation, we will use metagen function, and for the mean, we will use meta-mean, and then for mean difference and standard mean difference, we will use metagen function of the meta package. And then so for today, I will again repeat what we have seen last time, the metagen function, and then once we are done with that, we will use a different data set from what we did last time, just for a change. And then again today we will do the continuous outcome, and that's a pre-calculated effect size measure. So we will not pre-calculate the effect sizes, but we will use the pre-calculated. We will use a different data set which already has the pre-calculated effect sizes and standard errors, and then we'll use the metagen function to pull the effect sizes. So the data set, actually, it's coming from the book. The data set that I will use today, it's actually coming from the book that I already demonstrated last time in the beginning of my session. If you remember, there's these books that I really recommended. These are the two books that I recommended. So this book supplies some data sets that you can find online. I will drop this description. I will drop the link to find this data set in the description. In the description of this video. Here are some of the datasets that we can use. So for this one, we will simply use this dataset. You can also download the dataset if you want, but I will simply use the online version. So let me simply read this data, the CSV data, and to read that data, let me call it let me call it depression, because it's a depression dataset. It's actually a clinical trial on depression, I think, and then it's putting the number of people in the experimental and the control group, and the mean in the experimental and the control group, and then also it also has a standard deviation for each groups. So to read this dataset, let me just use the root CSV, and then I will simply paste that link, and then I will simply run it. So once now it's already read, let me again probably head. Let me see the head of that dataset. And so now this is how the data looks like. So you have the author, and this is pretty much what we would like to use. So what we want to pull, you can also pre-calculate effect sizes, but the good thing with the metagen is like you simply supply these values, and then once you supply these values, it simply so it's simply calculated by itself. Let me see how many studies we have. Let's check. So we have 17 studies, and then so it's kind of fairly large. Kind of, it's not really large, but that's okay. 17 studies is it's much bigger than the mostly most reported data. Sometimes if you are lucky, depending on the field, you may have like 100 or 50 studies. But otherwise, many of the topics, they are not really. You may not have as many studies as this one. So now we know we already have the data. So the next thing is we need to use the metagen function. So to use a metagen, I will simply use this, and then so metagen, the first thing is a number of group, number in experimental group. I already have NE and then NC. So NE is total number of the total number of people in the experimental group, and the total number of people in the control group. And then the mean, then we will supply the means, and then also we will need to supply standard deviations, and then finally we give the data, and we call that data depression. And then meter tau, of course, this is a continuous measure, continuous outcome. So we will use a gold standard. It's kind of gold standard, so we will use the value. And finally, we can also use this Hartung-Knapp adjustment for confidence interval calculations. We already described this in our previous video. You may go back and watch what this actually means. So as I said, Hartung-Knapp adjustment is for meta-analysis. If you have not many studies, if the number of studies in your meta-analysis are small, it's advisable to use this Hartung-Knapp adjustment. It's based on t distribution, so the confidence interval is calculated by the t statistics as opposed to the z statistics. So that means if your number of papers in your meta-analysis are like more than 30, this 30 is like a golden rule in t statistics. It's kind of a rule of thumb. So if it is more than 30, or maybe like a large number of studies that you have, that means the confidence interval that if you use Hartung-Knapp adjustment or not, there may not be any difference. But we will see again what difference it makes. I don't think there will be a big difference, but let's see. We will use this Hartung-Knapp adjustment as true, or other time we can use it as false. So now after that, I can simply use the summary function, or I can also put it in forest plot. So now I already have the individual effect sizes and the confidence interval for each, and we have the weight in the common and random effect analysis. So to decide which one to report, you will have to see the tau square, and many people use this I square value, but I think it's recommended to use the tau square. So still tau square, it's telling us that it's yeah, there is heterogeneity. We will come to this point later on, but for now you simply look at the pooled effect sizes. So the pooled effect size for random effect meta-analysis, it's telling us minus 0.6. If we use the Hartung Knapp adjustment, and then it will give us, this is a confidence interval. So maybe it's better maybe this way. Let me put it in a forest function, then we see the visualization. Yeah, so it's giving us the pooled effect size, but the study is 1 to 3 and then until 17. We probably can do better to improve this. Maybe we can do study lab, study, no, wasn't it study ID? Okay, label. I need to check what I have done it before. So it's like, okay, study lab. Okay, study lab. That's what the forest function requires. So study lab equals. So we have in our dataset we have order. So mainly we can simply use order. So we don't have to change anything. We will simply use order so that we can see the labels will be the order. Okay, order is not found. Study lab. Let me go back to my, so isn't this one? Study lab, okay, not study. Oh yeah, okay. That's our study label. It's taking a little bit of time, but it will do this later. So now we already have the labels, and the confidence interval is minus 0.98 to minus 0.23. Let me do again another forest plot, but this time without the Hartung Knapp adjustment, and then we will compare them. So now I will set this false. Then let me run the two meta-analysis, and then we'll see the difference in the confidence interval. Because it's the sample size are it's kind of okay, we may not have that big difference in the confidence intervals. Okay, now you see a little bit difference. Okay, so it's like minus 0.61. The main difference is in the confidence interval calculation. It's minus 0.98, 0.23, and it's telling you minus 0.93 to minus 0.28. This is where the Hartung Knapp adjustment actually changes. So it's a way that predict the confidence interval prediction. So it's the prediction interval. Prediction interval is something that we will also look at in the next sessions, because it's also important to report it. You can also prediction equals to, it should be like this, and it should work, I think. Then it will give you a prediction interval. But since that's not the focus of our today's session, we will not go into that. Yeah, so the prediction interval is this one, but we will talk about prediction interval in the coming sessions. So now this is how the meta-cont for mean difference and standardized mean difference works. Later we will go and others in the coming sessions. We will also see meta-core for the correlation and meta-mean for pooling mean differences. But for today, I want to again do this. Putting precalculated effect sizes. So for putting precalculated effect sizes, what we're going to use is this metagen function. So this is what we need, the metagen function. But for that we need data. I mean, you can also manually calculate these things. It's like we already have data, so we can kind of manually calculate the standard deviations. And then first you need to calculate the subtract mean experimental group minus mean control group. Then you calculate the pooled standard deviation. And then once you calculate the pooled standard deviation, so what you can do is like, okay, first you calculate the mean difference in experimental group minus mean difference in control group. Then after that means this is giving you the mean difference. But since we are doing standardized mean difference, we need to calculate the pooled standard deviation. That means standard deviation in the control group with experimental group. So you calculate the pooled standard deviation. Once you calculate the pooled standard deviation, that means what you do is you divide the mean difference by standardized mean difference. But that's not enough, because you also need to account for the hedges factor. Then you account the hedges factor. Then after that, that means with that you get the effect size. That means it's a TE. The TE based on the metagen function. We will see what TE is. And then the last thing you need to do is like you need to have the variance estimate, because that's also what you need. But for that, you can also calculate that. But I will not calculate all of this, because if you remember, actually I already described this in my previous sessions. We already have functions. If you actually, when we do this, when we were pulling effects mean difference and standardized mean difference from scratch, actually in the 5th or 6th session of my YouTube tutorials, you can find them. Here are the suicide prevention. So we already did calculated the hedges factor and things like that. Yeah, so I will not go into that. But if you want to, you can also do it this way. So let's say this is the pooled standard deviation formula, and this is the variance, how you calculate the variance. I also have it in my, maybe I can drop this in also YouTube, in the YouTube link. If anyone wants these notes, I can also drop that in the data sets that I use, maybe in my notebooks. I can also put it, if anybody is interested, drop me a comment and I will give it. Otherwise, you can also simply follow and use in your own way. Yeah, so let me just go down to where we are. Yeah, so for this I will use a different data set, and that data set is coming from this third web. This is third web. It's again a mental health therapy. So it's probably you can see one of these papers. It's kind of popular. It seems it's kind of popular kind of intervention psychotherapy. Yeah, so it promotes mental health. So we will use one data set. That's a third web data set, which has some studies. And then for that, what we need is this. We will need to upload the data, and to upload the data, simply we will simply call data, then we say third web, and then we will already have that data. So we already have that data. If we want, we can have a look at the data. Third web, and this is how the data looks like. So we already have the pre-calculated effect size, and then we have the pre-calculated standard error or the variance. So these are really the two things that we need for our meta-analysis, and metagen requires just these values and the data set, and that's all. Yeah. So let me pre-calculated, call it pre-calc. For the pre-calculated effect size, for two pre-calculated effect sizes, what we need is, as I said, a metagen function. Then after that, we need the effect size, and that's actually it's already defined here. We will simply define it TE, and then after that, what we need is the SETE, and that one is also defined as SETE. And then last, what we need is the data argument, and for the data is a third web. Then we already have our meta-analysis, but we can also put this Hartung-Knapp adjustment depending on the number of how big the number of the studies. But it's recommended if you really don't have more than 30 studies, it's recommended to use the Hartung-Knapp adjustment. But let's see how many studies actually we have for the third web. Let me just see the dimension of this, and we have 18 studies. So 18 is not bad, but still if it is more than 30, so the confidence interval will may match, because the T distribution and the Z distribution, they will kind of go in line. So the confidence interval will be will kind of match. So then using the Hartung-Knapp adjustment for confidence interval may not make a difference if your sample size is large. Otherwise, it's advisable to use it. Now I already have my meta-analysis. Let me run it, but let me call my summary, and then let me pre-calc. Then let me run this. Now I already have the meta-analysis, so this is giving me 0.57 standardized mean difference. No, not standardized mean difference. That is, I don't know, standard mean difference, probably it is, but this is just a pre-calculated effect size. I don't know all of the data, so it's giving me mainly the TE and the standard error. So this is the function that we use, but if we want, we can also see the forest plot. So I can simply use the forest function, and then it will, yeah, okay. Now again, we will also need to label this. For that, I think what we have is like, okay, we have order, maybe we have other variables. No, so we don't have that, so we will simply use StudLab. StudLab is order, then we will have the orders. Something wrong. Order not found. Okay. Okay, maybe let me use this, and let me put it this way. May work like this. Something is wrong. Forest StudLab. Forest pre-calculated StudLab, and then it should be. Okay. Then in that case, I will. Yeah. Okay. Possibly, what I can do is I can simply pass it here and give it like this. That should work. It's probably misunderstood. Misunderstanding. So it's like, okay, metagen, and then my order. What's wrong? We have already did this. Okay, what is the metagen? Okay, metagen, TE, SETE, data is some wave, and we are using Hartung-Knapp adjustment, and then afterwards we are using StudLab order forest. I don't get it. Okay, that's why A is capital. Okay, that's a problem. Yeah, now it should work. Yeah, now it's working. Yeah, so you have the effect size and the pre-calculated effect size. Otherwise, we can also do, let's say, pre-calc again. and then once we have that, we can call for this function precalc. Now it should work, but let me also use another function that is called update meta. So let me, yeah, okay, update meta is actually to step up, yeah, order, update meta order, and then forest. Then you can also do it this way, like this update. I'm using this update function just to show you can also use to update things, like you can do like a sequential, you can change something and then again you can use update. Yeah. Object is missing. The object is precalc. We forgot to add a precalculated effect size. Now it should work. Now it's already, so when we use the update meta function, we supply the our pulled this precalc, but we pull the studies, and then afterwards we supply, but we want to label it, we want to update this table, so you can use this update meta function and then still label it, and then you have yeah, you have your forest plot. So here again we are seeing 0.38 to 0.78, but we can also update this function by using Hartung-Knapp adjustment as false. That means we can update it as well. False is not really if you are using R, but if you are using Python you can write it like that. So this confidence interval will be different because we updated like Hartung-Knapp adjustment to be false. So that means we have a different confidence interval. So here we have 0.38 to 0.78, but here we have 0.41 to 0.75. Anyway, the intervention. I actually don't know what this intervention is about, but it seems I cannot say it's favoring or you know this. I mean, this is one difference, so that means or something is wrong. Maybe it's no, it's not wrong actually, because this is the effect size, so it's a positive change. So that means since the outcome is positive, so something like the intervention is changing. Maybe it's quality of life. If it is quality of life, so it's improving the quality of life, or maybe if it is improving something, then it's you have this positive change. So that means the intervention has some kind of effect, has an effect actually, like significant effect. But I cannot say what, because I'm not a content expert on this topic. I cannot really say something about. I just use the data, so I don't really know much about this. Yeah, so that's what I want to do today, metagen and metapoint function. So the metagen is to pull effect sizes of precalculated, to pull precalculated effect sizes, you can use the metagen function. Yeah, so that's all for next time. We will go through again metacore and metamean. After that, we will continue to subgroup analysis and heterogeneity estimates. Then we will continue to put in effect size of risk ratios, hazard ratios, odds ratios, and maybe prevalence also. Also, I don't really, yeah, you can also do prevalence. Then maybe later we can do publication bias assessments and maybe network meta-analysis and things like that. Until then, enjoy meta-analysis.